And welcome everybody to the Daily Space Weather. First thing we're doing here is we're looking at the sun in two ionized iron wavelengths, 131 and 94 angstroms. To see several sunspot groups, I'm just going to say several. At least 4, it looks like, sunspot groups at the moment. It's a dynamic environment, so we use the Solar Dynamics Observatory. Let's take a look at the magnetic fields. And you can see quite a lot of magnetic organization on the Earth-facing portion of the disk. Some active regions rising in the east as well. Let's take a look at the 4 corners. Here's the northeast. How about the southeast? How about the northwest? Spectacular close-ups here. And these wavelengths take 10 images per minute instead of only 2. 131 and 94 angstroms are unique to the Solar Dynamics Observatory in that aspect. Here's the southwest, which has the most active region on the closest star, sunspot 2871 there on the left side of your screen. Coronal mass ejection watch and solar flare watch remain in effect. The radio flux, I think it's only at 88. Here's the 1-year chart of that. No, I think it's up to 90 now. There's the 1-year chart of the radio flux. The black line would be the radio flux number. And here's the Space Weather Enthusiast dashboard. They've actually moved the geomagnetic storm forecast to just a few hours in the future now. Still forecasting a KP6 for I don't know. Apparently, they believe there's some sort of a CME from the 23rd that's going to strike today, and possible interaction with a coronal hole high-speed stream. I don't know. They're forecasting a nothing burger here, and we'll look more at that in a moment. First, global seismicity. So the largest quake of the past 24 was a 6.0 south of Greece here, in the Sea of Crete, actually on an island in the east central Mediterranean. There's the map of that. Again, it's a 6 magnitude quake coming in just a few hours from before we recorded the video. So we'll just scroll up the list here on usgs.gov. There was also a 5.7 at the Philippines at nearly 100 kilometers depth there. That looks like the second largest quake of the past 24. Some aftershocks there as well. Papua New Guinea. The Kermadec Islands saw 4.7. Tajikistan saw a 5.1. And let's continue on to look at volcanoes. La Palma is still erupting. That's the Canary Islands, by the way. It's exploding and producing a 5,000-foot ash plume. So a bit of a downtick there at La Palma. Subinosejima, flight level 7,000 feet there, 070. Flight level 070. It's a 7,000-foot ash plume. Nevado del Ruiz exploding, 20,000-foot ash plume over Colombia as a result of that. Sangay exploding, 19,000 ash plume over Ecuador. Revenador, 15,000-foot ash plume over that, also Ecuadorian volcano. It's exploding. Sabancaya exploding as well. 25,000-foot ash plume over Peru. Please don't pole vault the caldera. Please do visit our links. Please do support the channel via purchasing merch, becoming a member of the Smash team, etc. The print quality is spectacular. Tell your friends and foes, science noobs and science pros about the channel. We're also on BitChute. Notice how yesterday's Daily Space Weather Sunday Special received nearly 700 views on BitChute yesterday, and like less than 200 on YouTube. Thanks to our patrons, who've been historically the true source of funding for the content on the videos. Don't forget to press like and subscribe if you're enjoying the content on YouTube. Again, press share, leave a comment, etc. If you haven't checked out the Smash team yet, here's a little tidbit. If you click on posts, this is the view you'll see depending on your level. So as you can see, we're putting up all kinds of content nobody else gets to see. smashamash.com/smashteam. We're replacing Patreon with a vastly superior platform. It's just better. There are only 2 paid levels. There's a bronze level, which is free, and you get very limited information. There's a silver level, which is $2.99 a month, and there's a gold level, which is $9.99 a month, and also includes a paid-up annual option and complimentary merch, a $40 value. Anyway, welcome to the Neo-Renaissance. smashamash.com is our homepage. You can find links to the Smash team right there, and also links to our merch shop. So if you click on smAsho merch, you'll find our merch shop. Again, the print quality is spectacular. The designs are ingenious. We've ordered it in the order of best-selling. And welcome to the final few days of Smashtember. All the content will change, and I would remind all of our viewers to Mensa. And when I say Mensa, I mean make Earth not suck again. Has the planet been sucking in your neck of the woods? Well, it certainly has been sucking in my neck of the woods. The fascist shithole of Pennsylvania, thanks to Governor Tom Wolf. What a turd. Mensa, make America not suck again. And make Earth not suck again. It's up to you, not giant heaving bureaucracies that are unable to even get out of their own way, much less make healthcare decisions for you. We're also on Twitch. Look for more content coming there. Twitch.tv/smashamash. Install the mobile app and see when we go live, like we'll do later today, when we stream live our meteorology segment. So we've got some plasma on the way from a high-speed coronal hole wind stream, not from a coronal mass ejection. And you can see some spikiness happening here in the GOES magnetometer. So you can see the 2 different magnetometers diverging here, one showing lower readings, one showing higher readings. And for you new viewers out there, the N's and M's are noon and midnight local time for the satellites. Let's move on to look at some more magnetic data. Here's the heliospheric current sheet. It's part of the Gong 2 data. We show it daily. Earth is in a North Pole current sheet, as you can see here in green. We'll stop out on the last frame. There you go. There's a South Pole current sheet coming. And maybe that gives us some insight into the next activity. So anyway, here's the line of sight ecliptic plane field plot, also showing you the solar magnetogram. And you can see that blue line that's associated with the sun's B field. That blue line being pulled down to the south there as cycle 25 progresses. Here's the line of sight coronal hole plot showing the sun's B field in blue. And you can see some additional coronal holes rotating in here. Some minor coronal holes around the eastern equatorial zone there, right down there. Those are South Pole oriented, shown in red. And here we've brought up a visualization of this in 193 angstroms from the SDO imagery. And you can see a little bit of darkening there around the equator. Those are coronal holes. And speaking of coronal holes, here's the North Polar coronal hole. It's looking quite deep and defined here at the moment. And we also caught a little bit of a plasma filament here, basically an absorption feature, as it appears dark, not bright, in 193 angstroms. Great little filament there. I'll let it play through one more time. And here's our flare monitor and our detected sunspot groups. So at least 4 sunspot groups here. 2872, 2871, 2877, and 2878. By the way, 2872 has degraded to an alpha class. The rest are indeed still beta class, if memory serves. We'll show you high-res imagery at the end of the video. Here's your GOES X-ray flux. No major flares over the past 24. A couple of C-class intensifications happened yesterday in the realm of X-rays. No spikes on the proton flux. No solar flare-induced relativistic particles have struck Earth recently. Let's take a look at the real-time solar wind to see no sign of a coronal mass ejection showing up, and we're not expecting one either. I don't know why NOAA is. They've just misforecasted the coronal mass ejection. Anyway, current conditions are Just under 8 protons per cubic centimeter for the solar wind density, solar wind speed 385 kilometers per second. Just nominal levels here. If that's a coronal hole wind stream, it's a pretty weak one. Having only spiked up to about 13 protons per cubic centimeter there. Maybe 15. 15 protons per cubic centimeter is all we saw, and we've already seen a decline. If we see a weak increase in the solar wind speed, it's a very weak coronal hole wind stream. So here's the KP index, a measurement of global geomagnetism. It made it all the way up to 3. And yeah, not expecting a geomagnetic storm at all on the channel. We'll see what happens. Next, looking at the geospace here over the past 4 hours. The Space Weather Modeling Framework Geospace Magnetosphere movie. We're not expecting anything too exciting going on here. In fact, a little bit of a reduction in the pressure looks like it's happening in the past 2 hours. And indeed, you see that happening at the end of the video there. Here are ground magnetic perturbations, our other geospace magnetosphere movie showing changes to Earth's own B field here on the ground level. Quite a bit of magnetism here on the ground, actually. You can see pulses coming out of the Central Pacific Ocean there, as well as near the South the South Magnetic Pole, which is someplace around here. Also some perturbations there over Greenland, etc. That's 4 hours like the last video of data. Here's a diagram of the solar system. If you're wondering where stuff's located, we appreciate astrography, the location of things in space. Welcome to space. Let's advance it 1 week. And there's where we'll be in a week, approaching another new moon. My favorite phase. I'm a reverse werewolf. Were you aware? Also, here is the star chart of what's going on above my head right now. The moon is high in the sky and quite bright, passing through the constellation of Taurus. And that yellow line there you see is the ecliptic. The path the sun will take across the sky. The blue line is the galactic plane. Let's do a brief cosmology segment. Hubble. It's unable to see certain things, like vast amounts of energy coming out of the supermassive radio source at the core of this Seyfert 2 galaxy. So Seyfert 2 galaxy is a type of specific active galactic nucleus where we're oriented sort of on the galactic jet's coordinates. In other words, there's a jet coming out of this galactic core, and if we were viewing the galaxy more from the side, more from an edge-on sort of a view, it would be less bright. It has to do with the light and other radiation being emitted, visible light and other radiation being emitted from the galactic core, and our orientation with respect to it. So yeah, Hubble misses vast amounts of energy. So when we look at a quasar obscures the galaxy often because we're right in the jet. Also, a blazar is an even more direct view down the jet of a galaxy. NGC 5728 is the Seyfert 2 galaxy we're talking about here. And yeah, there's a lot of, quote, missing mass and, quote, missing energy in space, although it's looking less and less missing the more we look. The astronomy picture of the day is an interpolation from somebody's visor. So there's the original image, and here it is interpolated, flattened out, whatever you want to call it. It's the visor image from the moon. And it's Buzz Aldrin's visor, taken by Neil Armstrong. You can find it yourself at apod.nasa.gov. The astronomy picture of the day. Today we're not going to talk about a random number at all, or anything at the Neil Gehrels Swift-Bat X-ray Observatory. We're going to talk about IRAS 18089-1732, the quote star and quote forming region. The quote star forming region, end quote, located not far off the galactic plane. And we're looking at it here in infrared light. So there's an article here that we're going to show you in a minute. First, let's look at this in some infrared wavelengths. It's quite an interesting region there. And you can see various different infrared spectra showing up there. In this highly active portion of space. So it's actually exhibiting some spiral formations here, folks, an indication that magnetic fields are associated with star formation. However, they're not magic. So no matter what certain YouTube channels who don't seem to understand anything about the physics will tell you about magnetic fields being magical and doing all kinds of things that they absolutely don't do at all in space, let's talk about this article. The interplay between magnetic force and gravity in massive star formation. There is a play of gravity and magnetic fields. Once you have enough gravity, you have enough stuff there to produce coherent enough magnetic fields to produce magnetic field force lines like this. So that blob of infrared light that we saw also includes polarized light, which is what this imagery here is. And you can see these spiral formations forming in the nebulous cloud of gas and dust around this star or series of stars. Again, magnetic fields aren't magic, though. They have to be propagated by some sort of a semi-permanent object. They're not magic, folks. Anyway, here's a quote from the article. Contrary to their predictions, however, the magnetic field appears overwhelmed by another of the four fundamental forces in nature, gravity. Don't discount it, folks. It's all too real. It is associated with star formation. Don't believe the nonsense you may see on YouTube. And don't listen to Ben Davidson and Wal Thornhill and Don Scott. They are total and complete hacks who just cherry pick information and don't care about facts. Hacks who don't care about facts will try to tell you that magnetic fields are magic and that they're transmitted across the universe in ways that don't exist in reality. Anyway, that's today's cosmology segment. Check out our playlists. We have over 200 videos in our playlist for cosmology segments on YouTube, youtube.com/smashamash/playlists. Let's look at charging hazards. There are some minor ones over the Caribbean, Northern South America, Mexico, and Central America, about to move into the Central Pacific, most likely. Here's a one-year chart of relativistic electrons reported by Solon.info, and we're just in moderate levels of electron flux. Here is the 3-day chart of the electron flux measured by the GO-16 and GO-17. They're in a geosynchronous orbit. They're measuring the electron flux at the F ionosphere layer at about 300 kilometers of altitude using radiography. Here is your relativistic electron forecast model. NOAA forecasting flat levels of electron flux. I would forecast them down here lower, as, again, there is a coronal hole wind stream arriving, even if it's weak. Next, a diagram of Earth's Van Allen belts to show you the altitude of things like GPS satellites in preface for the total electron content forecast. And the electron belts are looking fairly organized at the moment. Nothing to write home about there. Here's another diagram of the atmosphere to show you where the F ionosphere layer is, right here at 300 kilometers of altitude. Feel free to pause the video if you're not familiar with electromagnetic radiation penetration or thermosphere temperatures. Here's your ionogram. And we're seeing some anomalies here in the high frequency variety, certainly. Both hemispheres. And you're looking at vibrational frequency here. Each color blob represents 1 megahertz, 1 million vibrations per second. So this gray area here is 14 megahertz. Aqua is 7 megahertz, and so on. There's the current image. Some high-frequency anomalies certainly there at 8:45 universal time. Here's the anomaly map showing you departure in megahertz from the 30-day median. Keep in mind, folks, the times of the equinox are the most geomagnetically active times on planet Earth. It all has to do with the orientation of Earth's equator versus the sun's, really Earth's magnetic moments. The location of Earth's geomagnetic poles are important in this as well. You can see those high-frequency anomalies showing up there in blue. Here's the latest image from 8:45 universal time. Some significant high-frequency anomalies over Oceania, places like Papua New Guinea and the central Indian Ocean. There's the ionogram, and there is the anomaly map. All right, and here comes some bonus features. We're going to show the Lermonth, Australia ground-based solar observatory here. Hydrogen alpha imagery to see lots of material here on the Earth-facing portion of the solar disk, lots of filaments. Coronal mass ejection watch and solar flare watch remains in effect, folks. Here come additional bonus features. The latest refresh of the colorized intensity, the intensity gram here. And that sunspot's been degrading. That sunspot there is almost completely gone. There's another sunspot that's now alpha class. That sunspot is beta class. And that sunspot group is beta class as well. Again, there are some active regions rising. There's the latest refresh of the colorized magnetogram. And we'll close things out with some full disk imagery here. Here's 304 angstroms. Great at showing filaments. How about a composite featuring 171 angstroms and 304 angstroms together? Possibly my favorite composite type view here, showing very different features in the same imagery. Ionized helium and ionized iron. We'll close things out at the low corona ionized iron 171 angstroms wavelength. Once again, thanks for tuning in. Congratulations on realizing our channel exists, and may that solar wind be at your back.